All right, everyone. It's about 12:30 right now, so we're going to get started. Welcome to today's webinar Wednesday on emergency stop and fluid power safety requirements. My name is Matt Higgs, and I'm an industrial automation specialist here at Shaker Yesco. Your cameras and microphones today are going to be turned off to keep things running smoothly. Please post any questions that you have in the chat, and we will answer them throughout. This training will be recorded and posted online for future viewing. So now I'm going to turn things over to Eric Cummings, an industry expert in the area of fluid safety, who will be our host today. Take it away, Eric.
All right. Thank you, Matt. And thank you for this opportunity. It's always great when we get to talk about how safety systems integrate with the fluid power safety devices that Ross has been providing for 60, 70 years now. So really the question, posed to me for this was, is all risk negated when an e-stop is pressed? And first we have to take a quick little dive into what e-stop requirements are. And that'll really lead us to answering that question. When we think about e-stop, first thing that comes to mind here in North America would be NFPA 79, the electrical standard for industrial machinery. It has some definitions for different stop categories and gets into the basic requirements of an e-stop. There's also IEC 60204. That's its comparable partner over there from an international standard standpoint. But really, when you get into ISO 13850, that's the first time that you see a standard that's really just about e-stop. So that gives you the most clear definitions and really the top requirements that you could possibly look for. But when you start to look at some of the ANSI machinery standards like B110, which gets into risk assessment and general safety of machinery, and then ANSI B1119, which tells you how to implement safety systems, that's where you get into a few additional type of requirements that are very helpful for people to be aware of when they're thinking about the fluid power safety requirements. So right off the bat, when we start talking about stop categories, this is out of 13850, but you'll find similar language in, NFPA 79. When we're looking at stop category 0, we're talking about the immediate removal of power to the machine actuators. And so when we talk about actuators from a fluid power standpoint, we're talking about, the cylinders and air drive motors, things like that are going to create motion. And then stop category 1 is where we're going to stop the movements and operations with power available and then remove the power. So it's more of a controlled stop than just removing power right away. And which one you choose is going to be based on what is the safest for your machine. That specific machine is going to function a certain way, and based on what those actuators are doing, that's going to decide which one you're looking at. So everything's going to have a category 0 stop, and the 0 and 1 is going to be operational regardless of the operating modes. And additional requirements that we talk about would be the actual devices being used for those stops. So basically, they have to stand out from every other device on the machine. They are intended specifically for emergency stop and not for other things. So the most common one that people think about are the push buttons, and they have to be activated by the palm of the hand. They really can't be guarded in any way. You also see a lot of ropes and pull cord type examples. Then you can also see foot pedal without that protective cover. And so really some of the requirements that we get into are making sure that these devices are easy to use as an emergency stop. And so what we see a lot of times are misapplications of e-stop. So you'll see things that are guarded. The US and European standards differ in some ways on this. So you may actually have equipment from Europe that meets their requirements, but not the NFPA 79 requirements. And we'll see foot devices that have a cover on them so that they prevent inadvertent operation, but if somebody's really trying to do it, they can't. And they're really not a lockout device. We see a lot of locking e-stops, and there are buttons that have a lock on them, which is an alternative measure, but they're not necessarily for lockout, tagout purposes of the machine to go in and do maintenance when you're looking at it from that perspective. So the push button specifically has to have a red button on it. It's a mushroom shaped button, and it has to have a yellow background. We do see a lot of issues with this. We actually do some lockout, tagout audits of customers, and we see a lot of issues where they just have not really updated to the new standard, similar to what you see there. They'll see it labeled emergency stop, but it's red. We'll also see other buttons that seem to look like emergency stops, but they're not. So it's really crucial that customers out there have the correct push button and the yellow background that goes along with it. There's specifications for pull cords. It has to be red, and the most important aspect of the pull cord is that it has to be tensioned correctly. You have to be able to pull that cord in either direction and have the e-stop work. You can't have it just tied off on a wall. If somebody were to pull on that, nothing's going to happen in one direction. So they have to be installed properly and tested to make sure that they are going to work in both directions. So those are some of the basics that we get into when we, oh, it jumped. There we go. That we get into when we talk about e-stop. There's certain specifications about where they need to be located as well. Obviously, at each operator control station, other stations determined by the risk assessment, right? If there are certain places where operators need to have access to the machine, it makes sense that you're going to have an e-stop in that location. So entrances and exits, anywhere that intervention is really going to be needed. And what's important as well is that they are directly accessible, right? You want them on the flat panel. You want somebody to be able to reach them very easily and hit it, because as the title says, it's an emergency stop. Somebody's seeing something that is unexpected, hopefully not dangerous, and they just want to hit that stop button. And if you're looking into specifics, it talks about the height there, as far as access level so that people can get to them. Foot pedals need to be in a fixed position right at the access level. So, every control station and access point has to have an e-stop, and it really needs to be accessible. When we get into B11.0, which again is safety of machinery, it really defines the risk assessment process for machinery. They have just a very simple clause about emergency stop, but it's very clear. Electrical, pneumatic, and hydraulic emergency stops shall conform to the requirements of B11.19 and NFPA 79. So what that means is that your pneumatic and hydraulic systems specifically are part of that e-stop system that's going to be integrated with your electrical controls. And for more details, of course, we would look at ANSI B11.19, which talks about the integration of safeguards. So when we look at B11.19, excuse me, which was updated just a few years ago, again, it talks about the category 0 or category 1 stop. And it says that you're going to choose that based on the risk assessment. Because as I mentioned earlier, different machines are going to have different hazards. Some may coast in a way that's incredibly dangerous, and that's not what you want to happen. So you want to make sure that you don't create hazards. It's going to meet the safety performance, the risk reduction as determined by the risk assessment. What we mean there, and specifically 9.2, is all about safety circuitry. If you decide that you need a control reliable circuit, to use the OSHA term, or you need a category 3 or category 4 type safety circuit on your machine, then the e-stop needs to meet that requirement as well. And of course, that's relatively easy with modern machines that are being installed. You're going to have an e-stop with dual contacts. You're going to integrate that with your current safety system. But we see a lot of older systems out there that still have single channel e-stop contacts out that could create an issue. So it's important to go back and relook at some of your machines and see if they're really what you think they are. But again, if you're looking at at having a control reliable system, that means that the fluid power devices would also need to be category 3 or category 4. It also talks about having a holding or braking function for these stops if you're going to have uncontrolled motion or hazards. Again, a lot of people, when they first read about e-stop, they think, oh, dump all the power. And that's true, but you don't want to create hazards, right? So that's very important. And again, we're removing power to the machine actuators. And we want to do this without creating other hazards. So again, it gives us a little bit to consider from our risk assessment standpoint and what we're going to do with our fluid power devices. So the first thing that we look to do is remove that power, right? We're going to remove the energy that's in the system from a pneumatic and a hydraulic standpoint. So the question that we ask customers when we do machine audits or we're sitting down and doing training is, is the pneumatic and hydraulic energy being removed from the actuators when somebody hits an e-stop? And that's a pretty simple thing to be able to verify. You're going to hear that air come out of the machine when somebody hits it. You're going to see, hydraulic actuators relax essentially. Removing the electrical power is really just one of the requirements when you're looking at a complete e-stop circuit. When we look at removing the pneumatic energy, we typically think of it as a safe exhaust function, right? We're going to block supply. We're going to exhaust all the downstream pressure. And we do have devices available that are a single channel category 1 device right up to a category 4 performance level E safe exhaust valve. So there's various options based on what the risk assessment says. But it's important that you know what you need and that you install it to meet that same performance level or category level that you have on your equipment for the safety system. We also have the option of a soft start for when you reapply the energy so that things don't suddenly move or you create hazards or damage to the machine when you reapply air. Because certainly we want to minimize any level of risk with the system. From a hydraulic standpoint, there's hydraulic block and bleed options. So this is a valve that we have available in 3 different sizes, 3 different flow rates. It's a category 4 performance level E valve, and it also has a built-in relief valve available with it. And when I talk about the category 4 performance level E, one thing that Ross does is we third-party certify all of our safety valves. We've been designing safety valves for the stamping industry since the 1950s. So we have a good amount of experience in that. We like to think we do it right, but we do want to go to third parties like TUV or DGUV and have them verify that everything that we tested meets all the requirements and that everything is exactly how it needs to be. So if you're looking at exhausting all the air or the hydraulics or block and bled, are you going to have motion? Are you going to have uncontrolled motion? Because as it's stated, we don't want to create other hazards, and we need to have some way of holding or braking in this category 0 or 1 stop if there's going to be uncontrolled motion or hazards. So again, there's a few options available out there from a pneumatic and a hydraulic standpoint. There's quite simply pneumatic load holding valves. Typically, we call these a pilot operated check valve. So technically, we're going to exhaust the air from the valves that are going to those actuators, but we're going to trap pressure on those cylinders that we want to stay in place that could create hazardous motion. It's a pretty common device that's used in machinery these days. And we actually have category 1 up through a category 3 performance level D option available just for these pilot operated check valves. There's also a control and load holding valve. This valve in the middle, it's actually a 4-3 closed center valve that's third party certified to Cat 4 PLE. So it's actually the control valve of a cylinder, but it can stop at any position throughout the stroke. And it's got redundant monitoring built into it to verify that everything is working as planned. So it's the control valve and the safety valve. So it's ideal if one single actuator is creating a hazard versus exhausting the air to an entire machine, except for when you're hitting that e-stop. So this could be the safety valve for that, whereas maybe there's a lesser category for the exhaust function. And then hydraulic load holding. We have a couple devices available for that as well. We're going to block and bleed the oil to make sure that no actuator motion is coming, but this is actually going to redundantly trap the pressure that's in that cylinder. And there's a few options available with this one, depending on what type of flow rate you need. And one thing that's critical when you go through the risk assessment is where you mount it. So this here, it's Cat 4 PLE, third-party certified, and it actually can mount between the manifold and the valve that's controlling the motion of the cylinder. It's got 2 sensors for feedback, and so if it's mounted between the valve and the base, it's very easy to install, and you would just have to wire it up into your safety system. However, in some cases, people are more concerned about hose breakage just due to the design of the system and their experience. And so it can actually be remotely mounted at the actuator. And so in summary, when you look at e-stop, a few things are clear. It doesn't just apply to electrical. It does include the fluid power. And when you look at what type of e-stop circuitry you have in there, from a electrical and a fluid power standpoint, it's going to be based on that risk assessment. And so if your safety system is required to be a category 3 PLD type system, then that's what your e-stop circuit should be. And that's what your e-stop pneumatic and hydraulic control should be. And then finally, if you're going to create risk by eliminating the power, there are other devices available to assist to make sure that you don't have that uncontrolled motion.
Thanks, Eric, for that presentation. If you have any questions, feel free to keep putting them in the chat. Eric, I actually have one quick one for you. For someone that might not be necessarily very familiar with the standards of e-stop requirements and maybe the fluid power safety ones, where do you recommend going as far as the standards are to kind of start that journey?
Big 3 standards that come up all the time from a safety standpoint would be B11.0 for risk assessment, basically. B11.19 for implementing safety systems, and B11.26 that has examples of electrical and fluid power circuits that are the different category levels. And then if I had to pick a 4th standard that goes with machinery in general, it would be ANSI Z244 for lockout tagout. Those are the primary ones that are going to guide you through the risk assessment process, the implementation of the safeguards that you choose, and making sure that you meet the category or performance level that you're looking for.
I knew you'd have those right off the top of your head. So,
and we sit on most of them. So actually, we sit on all of them. So we can be a resource if you or your customers have any questions as well.
Awesome. Thank you for your presentation, Eric, and for that overview of emergency stop and fluid power safety requirements. Thank you to all of our attendees for attending today's webinar. If you'd like more information on this topic or have any additional questions, please reach out to your sales rep, or you can email us at info@sydist.com for more information on today's topic. Our automation team, which I'm a part of, is also here and ready to assist in any applications that you might have. So with that, thanks for attending and have a great rest of your day.